Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Pyromania by Michael Lefkowitz. And you can tell why, actually, because of the burnt out parts of the grid. Anyways, here are the rules. Place one or more digits from 1 to 9 in every cell so that each digit appears exactly once in every row, column, and region. So the entire puzzle, you can only fit the digits in to the non-burnt parts. That's very fascinating, actually. When I did actually a run of this before, um, and I was thinking that instead of the I missed the part where it says place one or more digits in every cell, so that each digit appears. So therefore, this is the entire grid. You cannot actually place digits in the burnt out parts, which is actually very fascinating for what that means. Anyways, that is that restriction. It is not normal Sudoku rules because, again, the grid is only the parts that aren't burnt out. But you still have to place the digits 1 through 9 such that each digit appears exactly once in every row, column, and region. So that's actually kind of interesting of how that's going to work. We also have digits in a cage cannot repeat and sum to the number in the corner. So in addition to basically being able to place more than one digit in a cell, the digits in a cage cannot repeat, and they must sum to the number in the corner. Fascinating, actually. That's an interesting rule set here. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, that's interesting. I was going to say that there's certain things like, for example, the 17, normally it's 2 digits adding up to 17. But we don't know actually how many digits there are adding up to 17 here. There are also no repeats here. What does that mean? I'm not really sure. Here, there are 5 digits. Okay, so here there are, 5 cells. There are 5 cells here, which add up to 29, which means the remaining cell adds up to 45 minus 29, which is 16. But it could be any combination of digits there. That's the problem. So maybe that's not the best place to start. We know each of these digits must be in a separate box or a separate cell. Same here. Actually, all of these are separate cells. Let's mark those as green because those are single digits, right? For certain. Here, now we have 2 extra digits we have to add to row 4. We have 1 extra digit we have to add to row 3. We have 1, 2, 3, 4, 5, 6. We have 4 extra digits we have to add to row 2. Okay. Hmm. Okay, we have one extra digit we need to add to row 6. We have one extra digit we need to add to row 7. Okay, so this is one extra. This is two extra here. This is one extra. This is 6. 3 extra. Sorry, I think I miscounted earlier. This is 5 extras we have to add up to here in row 1. Ah, this is also full. So these are all good. These are all single digits. Interesting. Because that's all 9. So this is 5 we need to add here in row 1. 3 we need to add in row 2. 1 is in row 3, 2 is in row 4, 1 is in row 6, 1 is in row 7. 4, 5, 6. So we need how many? We need 3 in row, 3 extra digits in row 8, and then we have 5 extra digits in row 9. Column 1 needs 5 extra digits. Column 2 needs 4 extra digits. Okay, let's do this as, I don't know, in the corners. Okay. So again, we need 5 here, we need 3 here, we need 1 here, 2 here, none here, 1 here, 1 here, 6 here, no, 3 here, we have 6. 5 here. In column 1, it's 5 there. Column 2, we need 4. Column 3, we need 1. Column 5, we need 2. Column 6, we need 2. Column 7, we need 2. Column 8, we need 1. Whoa, really? Okay. That's very interesting. Okay, that's a very important restriction there. Didn't really think about that, but in column 9 we need 4 extra. So there can only be one extra digit. Okay, yeah. So that guarantees what this is then. There can only be one extra digit in all of column 8. So that means only one cell can be have 2 digits. And again, these 5 cells must contain digits adding up to 29. So this adds up to 16, and it can have at most 2 digits. So this has to be exactly the one that has to have 2 digits. So these all have single digits, and this has 2. So this must be 7 and 9 here. So that accounts for 1 here. So this cannot be, we have, so this is counting as 2. So we'll count that as 2. This then drops to 4 going this way. So that's 4 cells, 4 digits we need to account for. Right? That's interesting. These are single digits, so it's either 2, 6 or 3, 5 here. And the remaining digits have to be here, and we can only take 2 more here. Well, this can also take 2 more. And this can also, well, okay, so this these digits can only have 4 unique digits in this cage. So this can be only 2. It can only take 1 out of the remaining 4 unique digits we need. In fact, actually, this can never have an 8. So 8 always has to be in this cell here. But this adds up to 21. So this is specifically 1, 4 with 8. But 8 cannot be any of these. And we need 2, 3, 5, and 6. But, so how many cells are this? This is 4. Sorry, how many digits is this? 4 is here. This has to be 5 digits here. Which means the extra 2 digits are in these cells. So these cannot have extra digits. This can then have 2 extra digits. This could have 1 extra digit. And this could be 2 extra digits. Okay, so 7 and 9 cannot be in the remaining column or cells here. So where is the 8? The 8 has to be here, because 8 cannot be here or here, because they don't add up to, with any other digits, to add up to 10. This must be either a 3-9 pair, 4-8, or 5-7, because we know both of these are unique. Can only have 1 digit in them. 1 and 4 have to be here. So does 8, which means the remaining digits in the row in the column are 2, 3, 5, 6, 7, or 9. Okay. Hmm. Okay. Okay. So this could be 1, 2, and 3. If that's the case, I guess that's possible, and this is 1, 4, 5 here. Right? If this is 1, 2, and 3, there's only 2 possible ones in this. 2 digits that are missing that have to be placed in other cells in this box. So that's 2 in general here. Well, okay, sorry, this cannot be repeated. This is a single digit. So how many digits extra? We have 2 digits here. We have 1 digit here. So that's 3 digits. That requires then 6 digits in the remaining 2 cells. Well, they can only have 3 each. So they both have to have 3 each. So these are both 3. These have to be single digits because we've already used up the 2 extra digits here. So this is single digits. This is single digit. Whoops. We're going to remove the corner part. This then is 3 digits adding up to 6, which means this is 1, 2, and 3. The remaining cells in the box and the column have to be single cells. So this cannot be 3 and 9. It's either 4, 8, or 5, 7. This is 1, 2, or 3, which eliminates 1, 2, and 3 in the rest of the row that we have. This has to contain, so this is specifically 4, 8 with the other 5 or 6, which means this must be 5 or 6 here. But if this is 6, that requires this to be 1, 3. And if it's 5, it could be 1, 4, which is allowed. 1, 3 is not allowed because the 1, 2, 3 in this cell eliminates 1, 2, and 3 in the rest of the box. So this has to then be 5, which makes that 4, and this is 1. Therefore, this is a single digit here. This can't be 1 or 4. This can't be 5. That makes this 4, 6, and 8, which means this can't be 2 or 6. It's 3 and 5. 3 and 5 can no longer be here. This can't be 6. It must be 2, which makes that a 1. So we have 1, 2, 3, 4, 5 single digits, which means this must be 3 digits total. So since this is 3, one of these must contain an extra digit, but we're not sure which. This is 1, this is 4, 5. This must be 6, 7, 8, 9. Okay, this cannot be 2 and 6, so it's 3, 5, 7, 9 quadruplet. The remaining digits in column 8 are 1, 2, 4, 6, and 8. Okay. So all of box 2 is done, kind of done. This is 6, 7, 8, 9 here. 2 is here. So 2 has to appear one of these cells. It cannot, it could be two single digits. What digits are remaining here? One out of 3 or 5 has to be here. This is, wait, this is 1, 2, 3, 4, 5. Okay, this is not orange. This is even more than orange. This is, so what I'm labeling what I'm coloring the cells is how many digits each cell must have. Green is one digit, pink is 2, 3 is orange, 4 is red, 5 is going to be yellow, and 6 is going to be blue. Okay, where is this? Well, we don't know. Never mind. I was going to say, where is that digit? We don't really know. This has 1 extra at most. This is 4 digits. So we have 4, 5. It could be 6, 7, 8, and 9. Or actually, it has to be. Yes, each of these can only be 1 extra digit. So because of that, this is 4 total digits. This is a 5th one. We have 4 more digits remaining between 2 cells, and they both can only take up to 1 extra digit. So they both must take 1 extra digit, both, each. So this is pink, which makes these green and these green. So this has to be 2 cells, which add up to 2 digits, which add up to 14. Well, it cannot be 6, 8 because that would eliminate all possibilities for these 3, or it would eliminate 2 of the possibilities for these 3 cells, which leaving only 2 possibilities to fill out 3 cells. So that's not allowed. So this has to be specifically, whoops, let's not delete the coloring. This has to specifically be 5 and 9, which means this can't be 5 or 9. This must be 3, which makes that a 5. None of these can be 9. So this has to be a 6, 7, 8 triplet, which eliminates 6, 7, 8 in the rest of the row and in the rest of the box it's in. So therefore, this is 9. This has to be 2 and 4 exactly. So this is 2 and 4. This cannot, it has to be exactly 3, 4, 6, and not 3, 4, 3, 6, 7, 8. Okay. we have 2 remaining here. This could be 1 digit, or it could be 0. Oh, sorry, this could be 1 digit here, which makes that 3, or this could be 2 digits, which makes that a 2. Either way, it's kind of, we don't know. Okay, so this is 2 digits. We're not sure which. This is a single digit. These are all single digits. Okay. What else do we have? Okay, the remaining cells in column 6 cannot contain 1, 2, 3, or 9. So this is 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Okay. Hmm. Hmm. Okay. We have 3 extra digits in box 9. Actually, we only have 1 extra digit in box 6. Oh, we have 2 extra digits in... Okay. We have 2 extra digits in box 4. 1 is taken here. That means the other one must be here. So this must be a second extra digit, which means we have... This counts for 2 digits. 3, 4, 5, 6, 7. Therefore, this must account for 2 digits also. Okay. Therefore, this is 2 digits. That's 3. These 3 digits, 3 cells, must account for 6 digits. Only 1 could be here, potentially. Also, we have 3 digits here. That means these 2 digits must account for 6 digits. Aha! There we go. So, these 3 cells account for 3 digits each. Well, in column 2, we need 6 more digits. Therefore, 6 digits are here. This is 7, 8. Therefore, this must only be a single digit and is 9. So this must account for 6 digits here. This is then 7, 8, and 9, which means these are all single digits, right? Therefore, this does become an 8, 9, 8, 9 pair here to add up to 17. This is 6, 7, 8, and 9 adding up to 15 because it's a 6, 9 pair or a 7, 8 pair adding up to 15 because those are single digits. Therefore, this is 8 or 9, this is 8 or 9. That eliminates 8 or 9 in the rest of the column. So this cannot be 9 here. This is a 5, which makes that a 9. The rest of column 3 must be 2, 3, 4, 6, 7. Right? These are all 9 digits. 9 cannot be in any of these cells here. It can't be here. So 9 has to be in one of these cells here, which means this can't be 9. This must be 8, which makes this a 9. Therefore, this is a 7, 8 pair. 8 cannot be here in this cage. And again, you have to have the unique digits 1 through 9. You cannot have digits repeat in a cage. And we know there's 9 digits in this cage. So the 8 has to be one of these 2, which means this can't be 8. This is a 7, which makes that an 8. This can't be 7. Where is the 7 in this cage? Can't be any of these because it sees that digit. Can't be here. Can't be here because it sees that cell. It must be here. So this is 7. This is 9. This cannot be 7 or 9. So this is 3 or 5. This can't be 7. This can't be 9. This can't be 9. Where is the 9 in row 8? It has to be here. And the 9 can only add up to 11 with just 2. It cannot be 1 and 1 because those are repeat digits. So this has to be 2, and this has to be the 9 by itself. This can't be 2 anymore. None of these could be 2. Where is the 2 in box 7? It has to be here. But we're not sure where. And 7 cannot be here. This can't be 7 or 8 here. So this must be 6, which means this can't be 6. This cannot be 4 digits. Actually, where is the 8 in box 9? It has to also be in this 11 cage. Because it cannot be here, can't be here either, because this 8 eliminates that. So this must be a 3-8 pair. Because 8 can only be with 1 or 2 added to 11, or 3. But 2 is already in the box, so this must be 8, which makes this 3. This can no longer be 8. This can't be 3, so this must be 5. This can't be 5 or 8. 8 cannot be here, so 8 has to be one of these digits here. And this must be 2, because it can only be 2 at most. This has to be 4 then, 4 digits. So since this is 2 digits, that takes up all the digits here. So these all have to be single. Since this is 4 digits, that's 5, 6, 7, 8, and 9. So this must be single. Therefore, this must equate to 4 digits because that's the only remaining digits left. So this is 1, 4, 6, 7, and this must be 2 digits, right? Because it has 7 digits here. These are all 6, 1 each, so that's 6. This has to be, 3 digits. So this is 3 digits here, which makes this 2, 3, and 8. Or not 8, 2, 3, and 5. The remaining digits here are 1, 2, and 3. What are 3 digits adding up to 13? It has to be 3, 4, and 6, which eliminates 4 and 6 in the rest of the column. So this can't be 4 or 6. This can't be 4 or 6. This must be 3. This must be then 2. This can't be 2 or 3, so this is 1, which makes this 2. This cannot be 1 because of the 1 here. One of these is 7 or 8. One of these is 7 or 8, which eliminates 7 and 8 in the rest of the column. So this can't be 7 or 8. This 4, 6 pair eliminates 4 and 6 in the rest of the row. So this must be 5. This can't be 4 or 6. This must be 1. This can no longer be 3 or 5. These can't be 5. This can't be 1. This can no longer be 8, so therefore this can't be 4. This can't be 5 or 7, so this must be 8 and 4, which makes this a 7, which makes that an 8. This 4 makes that a 6. This is 5 digits adding up to 27. This is 2, 3, and 5, which forces this to be 1 and 4. These are 6, 7, and 9 remaining in column 5. But you cannot have a 6 because you can't have repeats. These two add up to 11. So the remaining 3 digits add up to 27 minus 11, which is 16. So it cannot be 7 and 9 to add up to 16. It has to be specifically 3, 4, and 9. So this is 3, 4, and 9, which means the remaining digits here are 1 and 2. Well, 1 can't be here, 1 can't be here, 1 can't be here because of this 1, 2 pair. This is remaining, this can't be 4, this is 1. So this must be specifically the digits 4, 5, 6, and 8. Where is the 1? The 1 has to be here. This can't be 4, so this is 6, which makes that 4. The remaining digits here are 3 and 7. This can't be 3 because of that 3, so this is 7, which makes that a 3. These, again, cannot be 9. This can't be 3. This can't be 6 because of the 4, 6 in this cell. So therefore, this is 7. This is 6, which this 7 makes that a 9, which makes that a 7. This is a 1 and a 5. And this last digit must be a 9, which makes this a 5. And we're missing, then this is a 2 and an 8. This is 2 and 8. And that's the solve. Yeah, I actually misinterpreted this earlier, so I just redid. I hadn't gotten very far before I realized that. So, but, yeah, I just completely ignored. I just skipped over from when I was originally doing this puzzle, the place 1 or more digits from 1 through 9. And I was, like, confused about how it was actually supposed to work. And then I reread the rules, so always reread the rules, and I got this from it. Pretty cool, actually. Pretty cool puzzle. Interesting idea about, yeah, limiting where things can be. I think I've run into this type of puzzle a couple times before. Um, I don't really remember. It was a while ago, though, that I did one of these. But this was actually very cool. It's sort of it's interesting restriction in itself of what digits can appear where, right? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.